Welcome to Microbytes. I'm Rich Bowers, and today I have one of my favorite guests always, Jamison, joining us. Jamison is a artificial intelligence data Gen AI expert and trainer. Good morning, Jamison. How you doing?
Hey, Rich. Great to be back again, as always.
Yeah, happy to have you. And today we're diving into Llama 2. Llama 2 just came out a couple weeks ago.
hmm
And Jameson, as always, right ahead of everybody, has been diving into this and reading papers, playing with it. And I said, who else is better to tell us about it? So, Jameson, we'll get started with Llama 2. The big thing that we saw is that it's described as an open source language model. What does that mean, and why do you think Meta decided to release it that way?
So, an open source model or open source development in general has certain advantages and certain disadvantages, of course. The main reason why Meta has decided to go with the open source model, Meta AI in particular, of course, tends to be a lot more research oriented. And they have found that sourcing out to the community and allowing the community to do their own research and post their own advancements and progress really helps in terms of community progression with the knowledge base of these models. And so with Llama 1 and with Llama 2, both of those are open source models, meaning that they are deployed on places like Hugging Face or other specific cloud platforms like AWS, Azure. They all host this model, but you can also download it yourself and run it on your own computer, which is something that isn't exactly viable for some of the other large LLMs like ChatGPT and Bard. So that's a major advantage for Meta for sure, because we can always use our own local resources to fine tune these models to our specific use cases and things like that. Really, really helpful for everybody overall.
And I think even Zuckerberg said it, right? Open source drives innovation because it enables many more developers to build new technologies, his quote.
Yep.
So you're spot on. You're spot on. That seems to be, their goal here. And, obviously in this space, you have more and more, it seems almost every day, but the big players, ChatGPT, Bard, Claude 2, and now Llama 2 stepping up over here. Let's talk a little bit about the features. And you kind of hit on a few of them. This is Llama 2. It's named 2 for a reason. There was a Llama 1. What do you think some improvements or changes they made between Llama 1 and Llama 2?
So a few major changes in the data field as well as the architecture of the model. I would say in terms of the amount of data that they put into Llama 2 in terms of training as opposed to the first version, there's definitely more data. I think I saw 40% more data than Llama 1. So that's definitely going to give it a broader and more up-to-date understanding of the world in general, which is really great. Some other improvements, and we don't have to get too much into this. I know this is a pretty short podcast, but if anybody wants to do any more research on their own, of course, the context length for Llama 2, meaning the amount that the model can process from your input, is double that of Llama 1. So that's going to allow it to generate more complex and nuanced responses as well. There are new activation functions within the model, new positional embeddings, and layer normalization. All of those, again, something that I can't get into too much. I would love to a little bit later if we want to get into more technical details, of course. But all of that is going to help the model understand what you're trying to say, keep context between your previous inputs and its own previous inputs, and sort of create more of a cohesive conversational paradigm.
Excellent, excellent. Are you setting up to come back on and talk more technical? I think that's what's happening here.
I'm always planning on that. Always a possibility.
So a few things actually I had questions. So you mentioned the content as in word limit, it's double,
Mhm.
right? I know ChatGPT is I think 25K on the GPT-4, right?
I believe so. Yes, that sounds about right.
Do you know what Llama 2 is or
I
an estimate?
think so. In terms of this is in terms of tokens, which isn't necessarily word length. A token is basically just a particular unit of speech or language that the model is able to interpret and understand. But I think with Llama, it's definitely smaller than ChatGPT just because it is open source and it is a smaller model in most cases. I think it's around 4,000, it's 4,096 tokens in context length, whereas Llama 1 was half of that. And I don't really want to do the math on that right now.
That's okay.
But, yeah, cool.
It's an early Friday still.
Yeah.
And just to clarify, because obviously a lot of people who are listening to this are in the Gen AI space or interested in obviously comparing the different ones. When you're saying tokens as a word limit, that's different than when we mentioned trained on tokens, correct?
In certain ways, it really depends on how the data is prepared. In most cases, how you prepare the data is how the model is going to be able to interpret it. So overall, a token is just a sequence of characters that's going to represent a meaningful unit of text. It can be a word, it can be a punctuation mark, a number, or really any other symbol that has any kind of semantic or syntactic role in the text.
Cool. So yeah, a raw text, I guess you could say, because I know going through this, what I was looking into was this was trained on 2 trillion tokens, right, as a platform, and I think Google Palm 2 was 3.6 trillion. So there's a difference between these models.
Definitely.
And another one of those is parameters. So 7, 13, 70 billion. What does that mean? What is that?
Got you. Yeah. So yeah, tokens and parameters are 2 very big things when it comes to training these models. When it comes to Llama, there are actually 3 different models, base models at least, that Llama has been trained for. There's the 7 billion parameter model, the 13 billion parameter model, and the 70 billion, and they're just named Llama 7B, Llama 13B, and Llama 70B. When it comes to parameters, a parameter is basically going to be, let's see, what's the best way to describe that?
Performance and accuracy? Is that correct?
Yeah, in a way, yeah. So the parameters are basically the particular attributes of those tokens that the model pays attention to and can change in certain ways via training the model, fine-tuning the model. It's basically the things that the model is aware of. So 7 billion parameters as opposed to 70 billion parameters. Parameters aren't just the only factor, of course, but it's going to basically be a lot more generally intelligent the more parameters you're able to train it on. So 10 times more parameters means not necessarily 10 times more efficient or more generally intelligent, but it's able to put in a lot more context into what you're saying and pay attention to what is going on there.
And thank you for that. Why are there 3 different levels? Is like all released, I guess, around the same time, right? Or so, but why are there a 7, 13, and 70 billion?
Now, that is an excellent question, especially when it comes to open source models. Having different sizes of models, that's really what this comes down to, allows people to utilize those models in different cases, right? So if you're making a mobile application, your phone uses models all the time already, right? With your autocomplete when you're texting things, that's actually using a very particular model. But it has to fit on your phone, right?
Makes sense.
That can't happen if it's too big. It's not going to be able to do much. And the video RAM, which is actually a good portion of where the computing comes in, especially on a phone, isn't a lot. So it really affects the length of time before you get a response in terms of the model size. So again, with mobile, you want a smaller model. If you are deploying a model for commercial or enterprise use and you want it to be high quality, you can actually host that model on, say, a cluster of a large amount of GPUs or graphic processing units. And that makes that model much faster. And people can access that model through endpoints, even while you yourself are hosting it. and then everybody's able to use it. So a lot of different use cases for different sizes of models. And that's why they tend to release different sizes at the same time. So people can utilize that quality of the architecture, but still be able to try it in different places, basically.
I mean, that makes perfect sense, right? I mean, especially in combination with the open source aspect, where they're saying, hey, look, go play, see what size fits whatever your mission is.
Right, definitely.
For just curious, for an everyday user, like say even yourself, right? Maybe you're incorporating it in some training or some projects, whatever it may be. Are you on a 713 or 70 billion if you're on your own computer?
Well, I only have, unfortunately, a single graphics card on my workstation.
Yep.
It's pretty good, but even then it's just a commercial card, right? So it's not going to be doing a lot. So I tend to still only use the 7 billion when I'm trying to do some research. In most cases, though, if you want to really deploy something that a lot of people are going to use, you're going to want to use the larger models, especially when it comes to machine learning operations.
Makes sense. And most people probably listening to this are going to be in a very similar boat, right? Where they're in that same rail. And that's what I was asking. I think at the high end, just for comparison, GPT 3.5 is about 175 billion. BARD is 137 billion at the top, right? So just a little, yep. Yeah, I would say so. So, okay, next thing, we knocked out the parameters, and now let's go to another thing that they were mentioning, Meta, that is the reinforcement learning from human feedback.
Right.
That's another feature. What can you tell me about, maybe what does that mean, I guess?
Yeah, that's another great question. And it's actually something that most of these companies are using when it comes to training these models with, let's see, the best process that I can explain this with is most of these models are pre-trained via unsupervised learning. So they're taking a look at all of this data and they are learning all of those patterns themselves, right? And so that basically gives them that understanding of the language that's going to give them the ability to, after fine-tuning and after more reinforcement learning, give a particular response. Now, when it comes to that more supervised aspect of the training process, once the model actually understands language, you still have to teach it how it's supposed to respond, right? That's where the security aspect comes in. That's where the quality aspect comes in. And a lot of that, not just with Llama, but with all of these larger models, the way that is done is via reinforcement learning with human feedback. And what that implies is a lot of people testing out this model, seeing the responses that they get, and then giving feedback on those responses in different ways, right? There are a lot of different things that you can tag and annotate in those responses and then feed back into the model. And that is a good portion of where this is coming from, is this quality of these models are tuned specifically for the conversational paradigm, right? The response and recall paradigm. And when it comes to that kind of reinforcement learning with human feedback, or RLHF, again, pretty much everybody is using that now because that's really the only way that you can get that kind of quality. There are some companies that are actually working on some more abstract models that are able to train other models to do this kind of thing, but that's still kind of in the works. And of course, those models are still trained by humans too.
And so a little scaling reinforcement, I think, right? That's for our Claude 2 discussion, I think, coming on up. So you mentioned, so the pre-training is self-supervised or unsupervised training. Then it goes to the fine-tuning piece, right? Which is where this kind of falls into place. Is that correct?
Mm-hmm. And that can be done a lot of different ways. You can have companies that will actually hire out people to do that specifically. It certainly is grunt work, of course, but you're still contributing, of course, to the model. I think in some cases, I'm pretty sure with BARD and with ChatGPT, you can actually give feedback yourself as a user of the model. And of course, that's not weighted as heavily as people who are actually hired for this process, but it does help the model as well.
Awesome. You went literally to my next question. I was going to be like, who's doing this, right? So learning from the preferences and ratings of the human trainers, those human trainers, typically, again, maybe a group of people that are hired on the back end, or even just us as the users making notations of I think it's the thumbs up or
Right.
the star or whatever it may be
Yep.
on these. Okay, awesome. Those are some of the primary features. Am I missing anything that jumped out to you in terms of features before we talk about partnerships and things?
Not necessarily. I think the main thing with Llama 2 is again that it's open source, but it is of course smaller than ChatGPT and Bard. But in most cases, it tends to be pretty much the same. It's just using more open source community defined techniques and architectures for its model.
Got it. Got it. Okay. All right, cool. No, that makes sense. And maybe we jump to security, actually. You mentioned security in the last piece. And on Meta's Llama website or the links that they give, that word is everywhere. Responsibility, safety, right? There's a lot of that mentioned, which is always good. I mean, we certainly want that. With that being really for me, the takeaways, big time when I'm on the site, when I hear, the company talk about Llama 2, how does open source help or hurt that? I think from somebody who's not as technical, certainly not anything close to yourself, if I hear open source, I'm like, okay, a lot of people can get in there then. So how are they balancing the two? Or are you saying, hey, look, it doesn't really matter if it's open source. It's okay. It's secure.
Oh, it definitely matters. That
Mhm.
definitely matters quite a bit. So it's certainly a double-edged sword for sure. With the transparency that comes with open source models, people are able to understand how it's trained, how it works, and that makes it a lot easier for malicious actors to exploit the model. So the main reason why Meta is so forthright with their transparency and so focused on security is because those two tend to go hand in hand with open source.
Got it. Okay. And they're even doing, I don't know if you saw this, they have a safety reward model in play.
I have not seen that.
Yeah, so I guess there's some way, same thing with the human reinforcement that we were talking about, or reinforcement learning from human feedback, just to be the right term there. I guess they're doing some type of variation on the safety reward piece too. So probably more and more is to come on that. Through my research, I didn't get an in-depth dive into it, but when we were talking about coming back and going a little more technical, that may be something that we go more into. But really interesting that they put such a focus on that and a welcome, right? A welcome certainly in this case.
Oh yeah.
I got two more groups for you, right? First one's going to be partnership.
Mm-hmm.
So a big partnership that was announced was Microsoft Azure uses it. And Azure, as we know, has a lot of security features. But it's Microsoft. And I think Microsoft has ties to another big platform, don't they?
Yes, they do with OpenAI. Yeah, OpenAI. I would say OpenAI and Microsoft are more closely partnered, but that doesn't necessarily mean that Microsoft can help out and be a hosting platform for other models from other companies as well. So that tends to be the case with not just Microsoft, but other cloud platforms as well. Google, AWS, they all have their own machine learning sections in their platforms now. But Microsoft has really taken the initiative in finding models that have been trained and are high quality already and allowing people who are using those platforms to deploy, fine tune, add their own data to these models to make it their own on the platform. And that's sort of the basics of machine learning operations, is sort of combining the DevOps with the machine learning and getting that sort of deployment pipeline going with continuous integration and continuous development.
Okay, and just to break that down a little bit, so we're obviously in still, we've been saying this every time we talk together, it's still in the newer stages, beginning stages of this. So as opposed to Microsoft kind of doing what Microsoft usually does, where they're using just their own products, they put their own products and things to bolster up the use cases. That's a shout out to the operating systems with the Internet Explorer, right? But it's still so new, so they're trying to see what fits. And using Llama with Azure, which is their cloud computing, or their cloud, right? Is there an advantage, you think, just kind of from your standpoint, over saying using ChatGPT?
Specifically with Llama 2 on Azure as a platform?
Mhm.
I would say yes, because in my experience, I'm using Llama 2 for, again, for research purposes, experimentation, all that kind of stuff. So it's more accessible for sure. When it comes to OpenAI and ChatGPT and having an endpoint deployed on Azure, you don't really get to mess around as much with it. I would
Mm.
say there's certain things that you can change, but again, Llama 2 is going to be a lot more configurable to particular use cases just because it's more open source and you have more access to more things on it. So when it comes to how Microsoft works with Meta and how Microsoft works with OpenAI, for them, it's going to be the same advantage. They don't have to train the model, they don't have to expend all of those resources. All they have to do is give you access to the model, give you access to the resources to run it, and let you do what you want.
Makes sense. It makes sense overall. I mean, time and whatever fits, their motive right there.
Right.
And while we're talking about partnerships as well, Hugging Face, and actually, I think you're the one that introduced me to this, and it's coming up more and more. What is Hugging Face, and should developers get more familiar with it?
Oh yeah. Yeah, I think in general, anybody who is into artificial intelligence or machine learning or even just software development, they should definitely be taking a look at Hugging Face because it has been a major player. I tend to equate it a little bit more to GitHub for classical developers. But there's subtle differences, I would say. There's the main things that Hugging Face has is its transformers library, which is a Python package, and obviously it's open source. Hugging Face is pretty much all open source, right? But it houses these implementations of different transformer models, and transformer models are basically what large language models are built off of. It's the architecture of those models. So anything from text, image, audio, all of that kind of stuff, multimodal tasking, all of that is hosted by Hugging Face in their library, and it's easily accessible, it's easy to use, and it's easy to develop models with this library. So that's one main advantage of Hugging Face. The other is its hub, which is basically GitHub, except for machine learning, right? So Git-based code repositories, again, similar to GitHub, and those include discussions, pull requests for particular projects, models, data sets, web applications where you can test out models in particular use cases.
Cool.
It's just it's a zoo for models. It's an absolutely incredible tool.
I can see the excitement in your face. And this is just to confirm, this is where you can download Llama 2's open source code, right?
Yep.
From okay.
And any other open source model that you can find, pretty much, those tend to be hosted mainly on Hugging Face.
Cool. So as a developer or somebody who wants to play with kind of the guts of these models, you need to know about Hugging Face.
Mm-hmm.
Last thing, probably an easier one for you, Jameson, as we wrap up. How do you find yourself using Llama 2 compared to Bard or ChatGPT or whatever other ones you're using?
Right. Yeah, personally, and this might be, obviously this is a specific use case, of course.
Yeah.
I've been using it on locally just to test out how exactly it runs on resources that I manage and administrate. So that's one big thing, being able to understand what is going on behind the scenes in a bit more in-depth fashion, as well as being able to experiment with the large language models in general. It gives you capabilities that you're not able to access, again, with ChatGPT or Bard, because those are hosted online, offsite, basically, right? And in doing so, I'm able to follow along with the more current research, especially with some of the stuff that DeepMind, Google's DeepMind, has been doing. And I'm able to see and replicate those kinds of studies myself, albeit on a smaller level, of course. But it's still really interesting to be able to actually see the progress and actually be able to do that on my own.
And that's the type of response you get from an expert in this stuff, right? Somebody who wants to dive in there and see how it works, the inner workings of, a clock in my mind, right? You're going through how do these things all partner together. And Jamison, as always, this has been outstanding, and incredibly informational. I think there's nothing left to do but set up another one of these to go more technical. So I'll get on your calendar, but Jameson, as always, I really appreciate your time.
Thank you, Rich.
Thanks for having us. And for Microbytes, I'm Rich Bowers. See you soon.